All right, we will start up Lecture 11, CSC 5323, 7323, Mobile Sensing, Learning, and Control. We'll get started. Okay, so the course logistics, A2 grades are going to be up sometime this week, but I haven't finished yet. A3 is due Monday, March 3rd, an hour after class, 6 p.m. Okay. Everybody okay with that? Okay. And we've got the updated schedule. It's sitting on the website. Everyone is okay with all of the constraints that app has to meet. Yeah? Step counting, activity detection, stair climbing. Okay. We will move on. If you got any questions, we can cover them in lab tonight. So today I want to talk more about basically our discussion about core image. Specifically, I want to talk, almost all of today's lecture is going to be about filtering and how to do it efficiently. All right, and it's going to be, I like this lecture a lot because the type of filtering that we're going to be talking about is image processing, right? So you inherently have this kind of tangible output that you can look at, which makes it a little bit different than audio. Because you can see what a lot of these linear operations and some of these nonlinear operations are doing, and it's a really good visual outcome. I think we will probably also get into video processing, so not just processing of images, but enhancing that, so we're actually going to have raw images coming in off the camera as fast as we can query them. And then I'd like to end today, if we have time, with face detection. And so we're actually going to do some live face detection on a video feed that comes in. Right, and this is essentially going to be part of the constraints for assignment 4 with the image processing lab. Okay, that is the agenda. Okay, so just as last time you saw the slide when I talked about what is filtering, and essentially I said it was the same as audio, right? We're doing convolution, which is a multiply and accumulate operation. All right, so essentially with an image, instead of having this big long filter that we want to multiply something by, we usually have small kernels, right? And so this kernel is a 3x3 filter. Everything is 0.1, so essentially 1/9 is the value here. So it's going to take the average value of the pixels, right? And so this essentially comes up here. It overlaps on all of these blocks, right? And so essentially, we take that filter and we run it across the entire image. We do a point-by-point multiplication with wherever that kernel is overlapping in the image, and then add it up to get the value of that pixel, right? And that's convolution for an image. That's 2D convolution, right? So that was a grayscale image that we did there. And then the other example I gave was, instead of an averaging filter, we had essentially this edge detector, right, which detects horizontal edges, right? So when we run it on the filter, we talked about there was an edge kind of in the middle of this image that we had, and it accentuated that right here, okay? If we want to do filtering, we don't actually have to do just linear filtering where we're doing a multiply and accumulate. In this class, we define a filter as anything that occurs inside of that 3x3 block, right? So if you were to go inside and take a max operation, right, where you have this 3x3 block, and you're just going to go through this image in 3x3 chunks and take the maximum value and set it equal to the center of the filter. That's called a dilation approach, right? And if we were to do that on this grayscale image, we would get this, right? Where essentially all of these values, now we have this like nice large contiguous regions of 4, there's a 9, all these kind of nice things. So this is actually giving us a nice kind of posterizing effect, right? Where we are taking the max inside of this block. So this is called a dilation approach. Is this useful? Did you use this approach in audio, where you took the max across a moving window? What did you use it for? Local maxima detection. Could you do local maxima detection with the same exact approach in 2 dimensions? Yeah, you better believe it. And it's probably the most efficient method for doing that. Okay, is seeing where those maxima equal each other when you do that and across an image. Actually, you can do that approach in any dimension. It doesn't matter if it's 1-dimensional like audio, 2-dimensional like here. You can do it in 3 dimensions, right? So maybe you're looking at video in that direction, or maybe you're just looking across color spaces, right? So you could absolutely do that. You could also do a median filter, right? So not just taking maximum or minimum, actually looking at, what's the median value that's right in there, right? And that's actually a really good denoising filter. It gets some weird artifacts because you get blocks in the image. You get this very blocky tones across the image, but it's good for a posterizing effect if you want to make it look kind of artistic. Yeah? Okay. So we're not dealing with grayscale images, though. We're dealing with color images, right? So how would you do filtering on an RGB image, right? So essentially, each of these now are color planes, right? So we're going to represent an image as the pixel values this way. These is the blue plane, the green plane, and the red plane on those sensors. How might you do filtering on a BGR image? Do the filter on each plane, right? And there are certainly filters that do that, right? So we could do edge detection on each of the planes. Or you might convert it over to grayscale, right? And that filter would essentially look like a point-by-point operation where I take a sum of the RGB values and save it into the output, right? Everybody okay with that? If I wanted to make something into grayscale, yeah? Good. But I could do that, and then I could run another, like an edge detection filter across it, right? I can convert it over to grayscale. So we're going to be filtering a lot of video in this class, right? So essentially, when you're capturing video from, let's say, the iPhone, the 5S, the back camera, right, which is the camera on this side, where you normally take pictures with, doing this, right? So not the front, not the face camera. That is capable of taking 8 megapixel photos. So if you were to look at that in RAW format, it's about 30 megabytes for a single image. Okay, that's a lot of data. If you're taking video, this thing can do 1080p HD video at 30 frames a second. That's a lot of data that's coming in. Okay? Even if we were to look at the face camera, well, it can do 1.2 megapixel photos, and it can do 720p HD video coming in, 30 frames a second. Okay? If we were taking video on just the face camera, and we were capturing at 1280 by 720, right? So that's 1080p. That's 1280 by 720 by 3 channels of data that's coming in. If it's coming in at 30 frames per second, that is 82.9 million samples per second that we have to potentially take in and process, and we want to do it in real time. So we need to do it fast. So let's talk about how to do it fast. You have to hardware accelerate this, right? We're not going to be able to read everything in, take it into memory, use the CPU as we go through pixel by pixel, everything that we want to do, and then take it back out, render it to the screen. Not enough time to even do that. Not a time at all. So how did we do this for audio? Let's look back. When we did audio, we looked at the VDSP, which is from the Accelerate framework, right? So the VDSP library. Why is this operation faster than this operation, right? So we have this VDSP. I'm going to convert this over to decibels. It goes through my magnitude buffer and saves it into here. Why is that faster than going through from int I equals 0 to k buffer length over 2? Yeah, it's using the DSP. It's using the DSP that's on chip, but essentially it's running multiple instructions at the same time. Right? It's called an SSE. Essentially, it gives one instruction, and it can do, you have multiple inputs, one instruction, right? So if you were doing say, a multiply operation with a log, you could do four things at a time, possibly, with one instruction. So one clock tick, you do 4, you increment by 4, and you can go through and go through and go through and go through, right? So even though you might have one multiply operation, you can get a lot of it. How do you do that with images? You split the image up. Right? If you were just going to do this normally on a laptop and you're going to process an image, what would be the best place to process it? The graphics card. We're going to do this on the GPU. Right? Essentially, we want to capture the image, and the image is going to be captured on the GPU, which we can do. We want to process it on the GPU, and then we want to render it from the GPU so that it never leaves the GPU. Okay? How do we do that? We're going to use the core image framework. And we're going to set it up really, really properly to be able to do that. So core image, it defines images in the context of CI images, right? So that's how you define the class. That is the base class for everything that we're going to do in core image. We use the CI image. It also defines a set of filters that can be GPU accelerated. So these are filters that can run on the graphics, on the image processing chip that's inside of the phone. They don't have to be run on that, right? If this is not a real-time framework, you can have the CPU do it. No problem. It optimizes filters when you cascade them, right? So all of the filters that we talked about before, we're just running across, that's embarrassingly parallel, right? But let's say we wanted to take a max operation and then a median operation. Well, it's not efficient to take the max operation across the whole image and then take the median operation across all of those. Those can be combined into one step, right? Where we do a single pass of the filter across things, right? So it's going to optimize a lot of those cascading the filters for us. So the way that we create filters is through an instance of the CI filter class. These are all of the filters that you have access to in the CI filter class. Okay? So CI image is something that's used not only on iOS, but it's also used on OS X. And there are some differences between how you use it on OS X versus iOS. So if you go online and you're trying to look up some stuff, they might be using things that are very particular to OS X that you can't use in iOS. Okay? And I'll show you how to kind of look at what's available in iOS. For the most part, it's pretty one-to-one, but there's a few filters in here that are only available on OS X that you can't use. Okay? Or OS 10. I always call it OS X. Okay, so nothing happens when you set up these filters until the image is rendered. Okay, so that is when you ask for that image back. Either you're going to save it into a UI image, or you're going to display it on the screen of the phone, right? So let's say you have this image here of the Statue of Liberty. You might do a contrast enhancement, right? So you do a contrast enhancement here. You kind of get rid of a lot of this haze that's in it. Essentially, you're just stretching the pixels out. Yeah? But then you might also want to do a posterization effect, right? Where you go through and essentially kind of take a median filter across this thing. And you get these large contiguous areas. Question?
So is the reason it waits until you want to display it is because it's storing it as compressed data before you want to display it? Or what's the reasoning?
The reasoning, but why it doesn't do it until render time? So it can do all of the optimizations. So essentially, let's say if I wanted to do this contrast enhancement and then I wanted to do a posterization enhancement, if I don't ever want to display this image of the contrast enhancement, there's no reason to do contrast and then posterization until I render it. Do you know what I mean? And so essentially what's going on behind the scenes is conceptually you can think about this as, here, I just did a contrast enhancement, here's the image, and then I did a posterization of that image to get this. What's actually going on beneath there is it's doing these at the same time, and any overlapping functions that it needs to do for both the contrast or the posterization is happening in one pass of the filter across the image. So that's why it's not done until render time. So if we want to load an image using the core image framework, then we're going to essentially, let's say we wanted to load an image just from the bundle, right? So we've used NSBundle before when we were using core data, right? We were essentially saying, we're telling the application, here's the application bundle. Here is where our MySQL database was. We're going to use the same thing here, except for images, right? So we're going to drag an image into our project, and we just need to create a CI image instance of that. Okay, so essentially I would do something like this, right? Where I'm going to get image path from the bundle right here. So NSBundle, main bundle, path for the resource. The name of the image I'm trying to get is image, and it's of type PNG. The file name and path of that I can get from this using NSURL, file URL with path. This is exactly like we did with core data. If we want to load up the image, then I'm just going to call CI image with the contents of URL, file name and path, and it will load up that image as a CI image, right? Pretty simple. So now, if I want to display that, image, I need a UI image. I can't use a core image, right? So there has to be a conversion between there. So I'm going to call on UI image the function right here, UI image, image with CI image, and then give it the CI image. Okay? When I call this function right here, it's going to get rendered into a UI image. So whenever I call this UI image function, image with CI image, whatever filtering pipeline I had set up before, all of that's going to happen, and then it's going to send me back this image that I can display onto the screen. Okay? Anything that I want to do in between, I could do some processing right here. Okay? Okay, so let's do some processing. I'd said before that we're going to use the CI filter class. So to create a filter in the iOS, we're just going to call CI filter, filter. And then I'm going to call this function on the class CI filter, which is filter with name. And then I'm going to give it a name of the filter that I want. Here it's CI sepia tone, right? So it's going to be a sepia tone filter that I'm going to apply to this image. And then I'm going to set up these keys and value pairs. Okay? So these keys and values define all of the parameters of the filter that you're going to apply to the image, right? So you need to tell it what the input image is, right? So this is just a constant, which is the input image, and then I'm going to tell it what the input image is. This is the input intensity, and it's 0.8, okay? And then I'm going to end the whole thing in nil, right? And the reason that I do this is that creates a dictionary, an NS dictionary. NS dictionaries are always nil terminated, okay? When I want to get the output of that, I can do it essentially in either of these ways, right? I'm going to call filter output image or filter dot output image. It's the same way. Same syntax. Sorry, different syntax, same functionality. Okay? Any questions on how I would set up a filter? Not bad.
What if you wanted to create your own filter and it wasn't one of the built-in ones? Could you do that with using some OpenGL and add it to like that backlist of filters somehow?
So you can do that in a limited way with core image, but you can define your own filters and your own operations, right? So essentially, any linear filter that you're going to do multiply and accumulates with, you can do it through the core image framework. If you wanted to create, say, your own median filter, right? It's not a linear operation. You're doing it's sorting and taking some stats of that. You won't be able to use core image. You'll have to do it with the vimage framework, or you could do it with OpenCV. Right? So when you want more control, core image is great because it GPU accelerates everything that you give it as long as you set it up properly. But if they haven't written the code for it, you're kind of on your own. The vimage class is very, very efficient. It also uses the accelerate framework, so it parallelizes the instructions. But it's a little more overhead. You can certainly do it with core image as well. You'll just have to convert it over to a core graphics image, so a CG image.
Or you could also put the image to like an OpenGL pipeline and just actually get the pixels that way.
Yeah, absolutely. Actually, and I'll give you code that does that. Okay. So now, instead of doing the self.sourceImageView.image for the UI image, all I'm going to do is take that with my output image right here, and I will have access to right here. So all of this filtering that I set up right here happens right here in that render. That's where all the processing happens for my CI sepia tone filter. Okay? To basically, if you want to go in and look at all of the image filters that are available to you from the core image framework, use this reference right here. You can get that from the slides. It's going to give you the names, parameters. It's going to give you examples for what all of those filters do and look like on their output. The best practice for those is to create the filters beforehand, because there's a lot of data that is stored inside of that filter object. So you don't want to keep creating CI filters every time you want to render. Create those in ahead of time, and then you can reuse the filters that are there. The one caveat that I would say is don't use CI filters in different threads at the same time. While CI images are thread safe, CI filter is not. Okay? Everybody okay with that? So if you were doing two images and you're just doing some parallel operations for maybe you want to render one and then render another a little bit later, don't do the rendering at the same time with the same CI filter.
You say set up your filters ahead of time, but it looked like you had paired the filter with the image, so the filter object was a filter with a specific image. How do you set up a filter so you can use it with any image and maintain the same? Or do you just call that?
I'll show you.
Okay.
Yeah. Essentially, you're going to use a function, which is you're going to set the input image separately. Right? So you're going to call filter, set attribute, input image, and then give it the
So
input
you don't
image.
set it all as one big thing.
Right.
Set the properties.
Right. But if it's not real time, if you don't need it in real time, you can do it. But when we get to video, that's going to become real important. Okay, so if you were to go on that website that I just displayed up here, you'll find references to all of the different filters that are up there, right? So this is a CI core image bloom filter, right? And it's going to give you a description. It softens edges and applies a pleasant glow to an image. Wonderful. That sounds really, really great. What it's going to give you is the parameters, the name of the parameters, and what they all mean. Okay? The one thing that you will need to do when you look at all of these core image filters is look way down at the bottom and look at availability, right? Because when you're on iOS and you ask for a filter that doesn't exist, the filter that it returns it's nil. Okay? And if you try to apply that filter, you are going to get a runtime error. Okay? Because you're trying to get back a structure, right? So you try and pass that message of, hey, filter this. And it's like, I have no idea what you're doing. Okay, so just check to make sure that it's available, and it'll tell you in iOS 6.0 or later. If it's not available in iOS, it will say available in OS X, and it won't tell you anything about iOS. Okay? So when you look at all of these parameters and everything here, let's say I wanted to apply the CI bloom filter, then I could create it, CI filter, filter with name, and then instead of doing that constant, which is K core image input, the huge kind of constant value, I could just say, hey, input image. I'm going to use the input image, right? So input image is equal to my image. And then I've got this input radius parameter, and I can put that in there. And then input and intensity, and I can put it right there. If I don't define any of those, all of them default to default values. So I could have created it like this, CI filter, filter with name CI bloom, and everything would be default. Okay? So the result of the output of that is this right here. You get this nice kind of, so we took Statue of Liberty here, and then we applied a little CI bloom filter. Essentially what it does is does edge detection, and then it applies kind of a white glow to all of the edges that you see inside of an image, right? So you get this combo, I don't know, it's like an angelic look to it or something. All right? This is just an example. You can do a lot with these. So let's do a quick demo of using core image in an application. We're going to call this Photo in Wonderland. All right. Yeah, okay. This is fine. So here's Xcode, and we'll create a single view application. I'm going to call it Photo in Wonderland. All right. The class prefix, call it Wonderland. For iPhone, next. Let's create it on desktop. Create. Okay, so preferences. Okay, so now I've got this Wonderland view controller, Wonderland view controller.m. I don't really care about memory warnings. Let's get rid of that. What I'm going to do is just load in an image right here in the view did load and apply a filter to it and then set it to a UI view. Okay? All right. So the first thing we're going to need in here is the image view that I want to set that to. All right. So let's make this. Go ahead and grab an image view, and I'm just going to drag it into my storyboard. Voila, just like that. I'll apply constraints to it, which is just I'm going to slave it to the... All right, so we're good. We've got an image view that's in there. The next thing that I'm going to do is control drag out on it, and we'll put it in here. Here's an outlet to it. I'm going to call it my image view. So now if we go back to where I created this, here it is. I've got my property, which is a UI image view right there. Yeah. So I can save a UI image into it The next thing that I want to do is actually, let's take an image. I've got one on the desktop here because I knew I was going to have this. Let's just put this into my supporting files. I'm going to create a copy of it right here. Okay, so this image looks like that. It's a caterpillar. Wonderful. And it's pretty. Kind of like this image, right? I could have given you a cat right here, but I didn't. You should be thanking me. No? What? What? Question.
So the image is like landscape or horizontal.
Mm-hmm.
Is it going to crop it, or what are you going to do?
It's going to squeeze it in there, my image view.
Okay.
Yeah. So essentially, you're right. You know what? Let's just fix that right now. Let's have this only run in landscape left and right. I only want these to be running in that.
Wait, what?
Right, so device orientation, I just took portrait off. So I'm going to say it's only available in landscape left and landscape right. Okay, so the first thing that we need to do is grab that file path, right? Okay, so how did we do that? Well, if I go back here to my slides, I'm like, how did he do that? Back here, or image syntax. It's got this file path, path for resources. All right, so let's do that. So I've got an ns string. File path is equal to, well, we're going to do an ns bundle. Main bundle. All right there. Okay, and then I'm going to get the path for the resource. Okay, so this is path for resource. And it was called cat with a lowercase c. And it was of type PNG. Yeah? Good. Okay, now we're going to have this URL. So I'm going to have NSURL, file name, and path. All right, and that's going to be equal to what? File URL with path. Yes, thank you, I do. Okay, so there's my file name and path. Okay, so I'm going to go up here and I'm going to import core image. Yeah? Really? I wonder why I did that. Interesting. Okay, so now I can create a CI image, right? And let's just call it the image is equal to CI image with contents of URL, and then we're going to give it the file name and path. Okay, so now I've loaded it up, right? I have a core image that I can do something with. What's the next thing I should do? Why don't I just set it to my image view? I can call it UI image with CI image, and then I'm going to give it a CI image. Happy? All right, and we're going to do some processing here. Yeah? Good? All right. So let's see how this looks. Voila. There it is on my phone. And it's looking very cool. There's my caterpillar. Okay, let's apply a filter to it. Okay, so let's create a CI image output. And let's set that equal to, I can call a CI filter. Filter with the name. Should we do the CI bloom? See what it looks like. We'll make an angelic caterpillar. Right, and the reason that I'm setting this equal to a CI image output is just because I'm going to say dot output image right here. So CI filter, filter with name, CI bloom, output image. Is this going to work? No. Does anybody know why, or just because I asked?
We haven't set the filter properties.
We haven't set the filter properties, right? In particular, the input image.
You're also not displaying output in self.image.
Ah, that's true. That's true. All right, so there's multiple ifs. So let's fix the first issue first. Right, so this should be keys and values, right? And so the first one that I'm going to get is, let's see, it's KCI input image key right here. Right, so that is essentially an input image, which is at input image. It's a string. Right, so there's my K input image key, and the input image is going to be image. Then it's going to be no. Okay, so I set the output right here, and now I want to display the output. All right. And there's a little bit of a glow on it. That's really tough to see. That's really, really hard to see. Here, let's do this one. CI hue adjust.
The negative filter, which like inverts all the colors.
Yeah, CI color invert. You could do that one. It looks funny. CI hue adjust, I think, is a pretty good one here. Anything that you put in here has to be, I don't know. I actually don't remember if these values are anything that's supported by CI hue adjust filter. So we'll just find out, see if it fails. Essentially what the hue adjust filter is going to do is it changes the angle of all of the colors that I see inside of my, so I'm pretty sure it just returned nil. Unknown exception, this class is not key value coding compliant for the key hue angle. Well, beautiful. All right, fine. CI color invert. If I had internet, I would just look it up right here. Okay, so I'll take that off. All right. We'll do a color inversion. Wow, there it is. Very cool. CI color invert. Look up the hue adjust as well, because you can essentially create false colors. So everything green turns to like blue and everything red, but it does it in a manner that's actually really efficient and really kind of cool to look at. Okay? Okay. So that was applying one filter. Feeling very, very good. This image processing stuff is really easy. We just have to use core image framework. So,
In that example, you had to create an image before you could process it with a filter. Is there no way to create an image with a filter in one go, or like one statement, or do you have to create two CI images like that?
oh no, you know what I could have done right here is I could have set this to image, right here. Do you know what I mean? I could have said, bam, image equals this, right? Where here's the input image, and then get the output image and save it into image. And then this right here is just image. So that is essentially, that's the in-place operation that you were talking about, yeah? Right? Does that work? It does, but we'll just do it. Voila. Good to go. Okay. Really? Okay. Oops. All right. Photos in Wonderland. Good to go. If you want to create your own custom filters, let's say you wanted a 3x3 filter, which essentially was 1, 2, 1, 0, 0, 0, -1, -2, -1. What does this filter do? Anybody? Yeah, not a posterization. It's really, really similar to the edge detection filter that I showed a couple of slides ago, right? I've got positives, 0, negatives, right? So essentially when you come across a vertical line, it's going to accentuate that, right? Because it's going to multiply. Let's say, we had small values and large values. Then when we add those up, we're going to get basically a large magnitude. But when we're on a relatively flat place, it's just going to multiply those and add everything up. It's going to be real close to 0, right? Because these cancel each other out. So here's the weights that I want to apply. Yeah.
So, when you say like adding, multiplying, it adds all of this stuff in the filter, I guess?
Yep. So inside that filter window, it's 3x3. So we just go across the image, multiply point by point each pixel with the filter that I have, and then add them up, and I save it in a new image, and the center pixel is the multiply accumulate output. Then I slide it over 1, multiply accumulate, and save it into that pixel. And just keep going forward, and then across each row.
For edge detection, don't you usually take the absolute value coming out of it so that you don't get like huge negatives and then huge positives?
You do. You normally do. Yeah. Yeah. Normally you square it, usually. Yeah. Yeah, for edge detection. Absolutely. Or you can apply a bias because maybe you want to be sensitive to only like increases. So you add, 100 or 150 essentially to it. So you get, if it's not an edge, you get grayscale. If it's a positive edge, you get positive numbers. Negative edge, you get negative numbers. Okay. So if you want to create your own, you can do this CI filter with name CI Convolution 3x3. They also have a 5x5 and a 7x7. Why are all of these odd? These numbers. So there's a center, right? Otherwise, it's kind of ambiguous, right? If I have a 2x2 filter, yeah, you can apply it, but where do you save the output? The upper left corner, bottom right? No, save it in the middle, right? So that's why everything is kind of odd. Okay, good. So I'll do a CI convolution 3x3, and then the keys and values that I give it are input image. Yeah, I get my image, but I can do this input weights vector where I actually give it a core image vector with values, and then I'm going to give it the weights right here. That weights, this CG float that I just created. Okay, so vector of weights, there's 9 of them. And then that input bias term, what I was just talking about, essentially I'm going to add a half to it, right? So that I don't get really large negative values. Okay? You can also chain filters together. And the way that you would do that is I'm going to just create an NS mutable array here. Filters. And I'm just going to allocate and init it, right? So I get an empty array. And then I'm going to do filters add object, and then I will just create and add filters into each of those. Okay, so now I have an array of filters that I've created. Okay? Now I just want to go through that array and apply each filter. And the way that I would do that is recycle the image that I'm using for output and input. So I'll have this output image is equal to my input image. I'll just set that up initially. And then I'm going to say, okay, for each filter in filters, filter set value, the output image for this key, right? So this is a new function, the set value function. but essentially I've got a filter that I've created right here. So I set value, I set the output image, and then I get the output image equals filter.output image. No processing takes place here at all, right? No processing takes place until it is rendered. Okay. So let's go ahead and do that. All right. So instead of essentially doing all of this right here, maybe I want to set up an ns mutable array of filters, right? So I'm going to create an ns mutable array of my filters. I'm going to allocate and init it. I'm going to give it, why do I always do this now? Okay, so ns mutable array, really? Sure. Okay. Now what? I'm going to add an object to it, and that object could be a CI filter, right? So I'm going to create a CI filter, filter with name. Seriously? Instead of hitting tab, I hit. Thank you. And what filter should we create? CI color invert. All right, so we'll invert the color. Great. That. Let's give a little more space here. And then we'll do a sepia tone filter maybe. Let's do a CI bloom. Okay. Why would I invert the colors and then convert everything over to sepia? I think everybody was okay with that. All right, that's fine. Okay, so now for CI filter in filters. Set value. And this is going to be, we'll just call it image for key. Input image. And then image is equal to filter.output image. Good? Will this work? You're crossing your fingers. I like that. This is good. Okay, well, let's see. Hey, it inverted the color and applied a little bit of a bloom to it. All right? It matters what order the operation of your filters occur in, right? Because essentially, it's going to do this color inversion, and then it's going to apply a bloom to that color inversion. I could have bloomed it and then inverted that, which would have given me a slightly different effect right here. Okay? Because it would have inverted that white bloom color that you see on the edges right here. It would have been darker. Okay. This is pretty good for photos in Wonderland. The caterpillar does this. Next, we could have done a Mad Hat or something. Okay. So, all right. To access the camera of the device. And if you want to access the camera for just photos. It's very easy to get photos. All right? You use this image picker controller delegate protocol inside of your application. Right? And so essentially you declare yourself as a UI image picker control delegate, right? Where we declare protocols up at the top, right? So this could have been your view controller. And if you want access, so that will give you access to the library. So what that is going to do is it's going to allow you to essentially present a modal view controller on the screen that gives access to someone's camera library. And they could choose an image, and then you can get that image back from the user. If you want to do it from the camera, you can do the same thing. You declare yourself as a UI image picker controller delegate. You implement this protocol, except you're also going to call this thing on your image picker, which is camera UI.sourceType equals UI image picker controller source type camera. So instead of going into the albums to get this image, it's going to go and it's going to ask the user, it's going to pop up a generic little camera, and they're going to be able to take a picture and save it out to you. And you're going to be able to get access to that, right? If you want some detailed instructions on how to actually use these protocols, you can go up here into the, essentially it's the iOS documentation to get access to those if you want to access the camera. I'm just going to do this as a really kind of quick overhead, and then I'm going to go straight into video. Because getting video is a little bit harder, and I want to go over it in more detail. You guys can do this on your own. But essentially, you're going to declare yourself as a UI image picker control delegate and a navigation controller delegate so that you can dismiss and present modal view controllers. This right here, this example, uses a button. So I've got some button in my storyboard. When that button gets pressed, this is what happens. I'm going to declare a UI image picker controller. I'm going to call it myPicker. And then I'm going to allocate an init. I'm going to say myPicker.delegate equals me, because I am the delegate. I declared myself up here. And then present view controller, myPicker, animated yes. That is going to present a modal view controller that allows people to go into their library and get access. Because I'm implementing this protocol, I get access to two functions. One is image picker controller did cancel. That is when the user does not pick an image, and you just want to dismiss the view controller in that case. So self-dismiss view controller, yes, completion, no. You can also implement this. So image picker controller picker did finish picking media with info, and it's going to give you some info about what they chose. So essentially, I could dismiss the view controller is the first thing I want to do. I want to get rid of that modal view controller. And then this info that comes back, I can say object for key and get the original image. I could also set this up to where I allowed editing, right? So you could have the user, maybe they took an image or they selected an image from the library and cropped it up, right? And then you could get access to the edited image right here, right? So you're just getting it. So this is going to be a UI image that it returns, and that'll be the picked image. Okay, there's plenty of examples out there. This is a really easy thing to do. If you want to take a photo from the user, you're going to do everything exactly the same, except right in between here, you're going to say myPicker.sourceType UI image picker controller source type camera, right? And if you go onto the iOS Stanford course, they have a really good example of doing this. Okay? I'm going to leave it there. We're going to go to video. Raw camera access. All right, and that's what this is. It is raw camera access as fast as we can get it from the screen. So we want to access incoming video in real time and display it on the screen. There's going to be a lot of processing in this step. So our setup needs to occur in conjunction with our GPU. Essentially, we want to set up a proper context, which is something that was taken care of for you with the OpenGL library when you were displaying the audio onto the screen. But we also want to set up everything in conjunction with our renderers and the processing pipeline which we have. Okay? You need to understand what we're doing here. You are not going to have to write the code to do it. Okay? But I want you to understand what this process looks like. Essentially what we're going to do here is we're going to create an AV capture session. All right? So this mediates all access to the incoming video and access to the screen, right, of the phone. So the screen output image and camera image, essentially you just have to make it so that they are representing images in the same way. Right? So we have to make sure that they have the same color representation, because you can represent things as RGB or BGR, right? So essentially we have to make sure we're in the same color transformation. We also have to apply any transforms, right? So if we want to You know, if you're taking images off of the camera, what orientation are those images in? And is that the same orientation that your context is displaying things at? Like, these are really low-level things that you have to get right. Right? Are you mirroring the image? And we have to set up the rendering context so that they never leave the GPU. Okay? So this capture session, this AV capture session, this is optimized for doing things like if you were going to write a Skype application or a FaceTime application, right? So essentially, you're going to, all the setup for this happens with, hey, I want access to essentially audio and some video, and I want it to be at this kind of frame rate based on if I'm on Wi-Fi. Or I want it to be based, you know, maybe I'm using the 3G network and I want it to be really, really low bandwidth. You can set up the AV capture session to only capture it, say, like 5 frames per second, which is, you know, decent enough for video and really low qualities. Okay? So inside of AV capture session, you can tell it the device that you want to capture from. Essentially, you want it the front or the back camera. Those are the only 2 devices you have access to. And each of those are AV capture device position front or back. So this is just an enum. And then this is the quality preset that I was kind of talking about before, where you have this AV capture session preset photo, absolute highest quality image that you can get. That is an 8 megapixel photo that it is trying to capture in real time from the camera. Okay? You're not going to be able to process that in real time. And even if you wanted to display it to the screen, you'd be processing way more pixels than you're actually displaying even to the retina display. That make sense? Then they have these kind of generic high, medium, and low presets, which essentially are for, like, high would be if you were on Wi-Fi and you were going to use Skype, you would use the high preset, right? If you were on 3G, you would probably use the preset low, right? So these control things, both the frames per second that you're allowed to capture at and the resolution, right? And then there's some other canned resolutions that you can get, which are, you know, this is 720p, here's 1080p down here. And then they also have things, say, if you were capturing on a VGA, the phone is on a VGA input, you could do it for 640 by 480, etc. All right? So that would be if you were doing AirPlay. So the conceptual architecture behind this is you have the AV capture section is mediating all of the access to all of the data that you have, right? So it's got a capture device and it's got a capture output, right? So the capture device, we want to take it from the device, render it straight to the GPU. The capture output, we want to render it from the GPU. And in between where we do all of our processing, we want to do that on the same pipeline where the AV capture session is grabbing things and rendering things out. We just want to insert our processing code almost inline right in there. Okay? And we want to do it in such a way that it never has to copy it over from the GPU. Okay? Data transfer between the GPU takes a while. All right? Everybody okay with that? So, how are we going to program this up? What did we do with audio? We used Novocaine, right? I didn't want you to reinvent the wheel. Same thing. We're going to use something called video analgesic. All right? This is a class that essentially takes the pain out of GPU capture, render, and processing. Okay? And it's going to be really, really, really similar to the Novocaine example. Okay? So, I'm going to import videoanalgesic.h, property strong non-atomic, and then I'm going to create an instance of video analgesic. I'm going to initialize this, right? So let's say that I actually, let's say that instead I called this class the capture manager instead of video analgesic. That's a typo on my part. So it would be self.capture manager. This right here should be capture manager. Then I would just create a new instance of capture manager right here, the same way that you did with Novocaine, where you got audio manager. If I want to start it up, I'm just going to check and see if it is running. If it's not, I'm going to choose capture manager start in the same way that you did something very, very similar with Novocaine. I can also set up some options, right? So self.capturemanager.preset. That's where I can set up this. See, so I'm going to say AV capture preset medium, pretty good on Wi-Fi, pretty good on 3G. It's essentially the quality is going to be coming back, and I could capture at 30 frames a second. I could also say self.captureManager set camera position, and then give it one of those two enums that I talked about before, right? So this one's going to capture from the front camera. The front camera is the face camera when you're doing a selfie, okay? Then if I ever want to stop the capture manager, I'll just call self.captureManager stop. This is all set up for you to render and display from the GPU. You don't have to do anything. All of that code that I talked about before is done right here. In the same way that when you took Novocaine, all of that rendering was done for you, right? So, processing. Very, very similar to the way we did in Novocaine. How did we process things on Novocaine? Somebody, anybody, yell it out. Set input and output block, right? And on the input block, we had, data, num frames, num channels, right? Now, what we're going to have here is a process block called right here. So self.captureManager set process block, CI image, camera image. So the input that we get is the image from the camera, whatever camera we've set it up to display from, right? And it's already set up as a CI image on the same context as the GPU. Then, whatever I do in the processing steps right here, I'm going to return the image. So if I were to call this right here, what's going to happen? It's going to display the raw image to the screen. Whatever I return right here is going to get displayed to the screen. Okay? So I could declare a CI filter right here. So I'm going to give it the block command so that I can actually manipulate this filter inside of a block. Everybody okay with that? So I'm going to say block CI filter, filter with name. I'll set up any of the parameters that I want to before here, and then I'm going to set process block, and I'm going to say filter set value camera image, which I got from in here in the block. I'm going to get an output and return it. Okay? You could also set camera image equal to the dot output image and just return camera image right here. That way you wouldn't have to create another CI image instance. However, this creation of a new CI image, low overhead. Why? Because nothing gets rendered to that image until I ask for it. Okay? So let's do a video processing demo. And we'll call it Looking Live. Somebody get that reference? No? Brent Musburger? Somebody. So I see one nodding head. That's fine. He's still alive. That's fine. Yeah, you are looking live. Yeah, it's fine. Okay. So essentially, Photo in Wonderland. Yeah, let's go ahead and keep. No, we'll just create a new project. Stop running. Delete that. Xcode. File. New. Project. Single view application. Next. Looking live. Looking live. Next. Create it on the desktop. All right, looking live. I dropped the G because we're in Texas. I grew up in Oklahoma, so I already did that. All right, so here we go. So the first thing that I'm going to do is I've got video analgesic. I'm going to take that and just put it inside of here, copy items into the destination folder. If you want access to video analgesic, you just download it from Blackboard right after this lecture. Okay? So let's look at the public API for this. Wow, I've got access to a lot of different stuff inside of video analgesic. I've got this process block, right? So it's going to give me an image, and I need to return a CI image. I've got these things that I can query, like video is running. I can get access to the capture session queue. There's all sorts of stuff that if you really want to get into this, you can do. Okay? You're also going to have access to all of these different things like starting, stopping, is running, and set camera position. Okay? So, my Looking Live demo right here. Let's do this. let's create a property. Well, let's first import it, right? Okay. Let's create a property here at property strong. If you're not bored right now, you should be. On atomic. What am I going to call this? Video analgesic, and we'll call it the video manager. Okay? Very good. So, our video manager right here. Oops. If it doesn't exist, we're going to instantiate it and make it exist. Right? Actually, yeah, we'll just do it this way. So let's do it with lazy instantiation. All right, so we're going to have this return a video analgesic. Oh. Stop, seriously. Okay, so we're going to do video manager, open it up. We're going to say if underscore manager this, except we want a not in there. So if it's not defined, then we want to return it. Okay, so if it's not defined, all I'm going to do is I'm going to say underscore video manager is equal to what? I'm going to call a class function, which was video analgesic. Analgesic just means painkiller, by the way, if anybody was wondering. And what did I call this? Capture manager? Yeah. Capture manager? You want to call it something else? We can call it something else. No? We're good. All right, let's call it this. Oh, capture manager. This is a function. So I'm just going to get access to the capture manager right here. Right? So when you were using Novocaine, this was audio manager. Here's just capture manager. Okay, if you wanted to, you could manipulate video analgesic to also do audio in the render function, right? Okay, great, excellent. So now we want to set up some options. What were some of the options that we had? Let me look back here. So if we look back at the slides, there was a preset option and a capture manager set camera position option, right? If we don't want to use the defaults there, then we want to set the preset and the capture manager. Okay, so let's go ahead and do that. I'll say self.video manager. Let's do .preset equals AV capture session preset set. Let's do medium. We'll keep it the same here. Okay. And then we want to set the camera position. Self.video manager set camera position AV capture device position device position. Let's do front for selfies. Good? What? It's easier for me to do from right here. Okay. Is this going to work? No. It's not going to work. Why not? Yes, both. All right. I didn't do anything with the input, and I didn't call start. Okay? So maybe where should we call start from? So immediately when I call start, it's going to start capturing images from the camera and displaying them onto my view. Yeah, view will appear. All right? Why?
Because that's the last frame you loaded. The last function called for loading.
Yeah. If I do this in view did load, whenever my view appears, if I do this in view did load, I could create the view controller. That view controller might not even be seen by the user, right? So if I'm in a table view, I could go back to the table view, but if my view controller still exists back there, it might still be trying to display to screen. It's just getting covered by another view controller, right? So in view did disappear, I want to stop this thing, right? Or view will disappear. I want to stop it. That means that every time in view will appear, I want to start it up again, right? Everybody okay with that? Cool. Good. All right, so view will appear. Voila. Okay. Okay, so we'll do self dot video manager start. Voila. And then in view will disappear. Let's call it disappear. Do I want to put self.videomanager stop or start before or after the super? Before. Yeah. Essentially, I want to do all of my deallocations taken off the screen, then call the super, right? So that it can do all the stuff that it was going to.
Is that like animation? What's going on with it?
Well, oh, with the animated?
Well, with the super.
This right here. So I inherit from UI view controller, and anytime, if essentially, if we didn't overload this function right here, it would call the super class for UI view controller to do all of the deallocations for view will disappear. Right? So any of the custom things we want to do right before that. Because we want to get rid of everything that we were going to do, then have it call the super controller so it gets rid of all of the, essentially that fits right into the life cycle of the view controller. Are we okay with that? Okay. So let's do self.videomanager stop. Okay, now I'm feeling really good about myself, right? Except for right here. I'm actually going to check to see if self.videomanager is running. If not running, then I want to start it. Okay? And I want to do the same thing right here and say if it's running, then go ahead and start. Why would I do that? Yeah, essentially, right, I'm not exactly sure how I'm going to use this view controller in the future. I might be popping in and out of it a lot, right? Some things, it may not have been completely deallocated by the time I try and load something back up again. There's a lot of things that can happen in the view controller lifecycle. And so to be just good programming practice, we want to make sure that we're only starting or stopping something when we need to, right? Okay, so should we run this? Let's run this. Nothing. What's going on? I did not do set process block. So let's do set process block. Oh, wait. Just kidding. Active format pass is not supported by the device. Use formats to discover valid formats. What did I do? Preset. AV capture sets preset medium. Camera position. In front. Da-da-da-da. Interesting. Yeah, it could. It absolutely could. So essentially, format locking. Well, we got rid of the error. I will fix that in the code before I upload it. Yeah. Okay, so let's set the process block. Right? So self dot video manager set process block. Blah. Okay, so we're gonna have a right here, which is CI image camera image. Return camera image. Right? So we'll just return the camera image. So let's see if that works. Seriously? Interesting. So that should have worked. And it did not. And we have 8 minutes left. So we need to figure out why.
The presets work differently for the front camera and the back camera.
Perhaps.
Can you query what formats are supported before you set that?
Well, this the preset medium is actually the reason that is there is that it works on both the front and the back camera. If you're not specifying a resolution, you know that the medium, no matter which one you're at, it'll actually give you the right one. I'm wondering, was that it? I wonder if I'm just going to check this out, make sure. What did I do here?
What seems to be in this logs now.
All right, let me make sure that this is not just an AirPlay issue. There. Okay, it's not. Interesting. This doesn't seem right. Well, I will figure this out, and then we will get back to it. Does anybody see anything right off the bat? It's going to be something ridiculous. Like I didn't actually instantiate or start something. Oh, essentially, it should work like this right here. So essentially, I've got a capture manager. Oh, no. Did I just not remove the background color? Hold on.
Could it be that you're trying to process a block before you started?
No, yeah, I didn't get rid of the background color while I was working. So essentially, what the way that this is set up, it is set up to be the very back, so that you can put UI elements on your storyboard and have them show up, and they're always in front of the camera that's getting positioned, right? So let me AirPlay this. There I am. I promise this is actually running from here.
How do we know that isn't just
How do you know that it's
the
not
thing
just...
that's always going
The thing that's always, that's true, that's true. Here, I'll start it, stop it. Oh, that's how you know. That's how you know. Okay, so don't forget to set background color equal to nil. I even forgot that from the slides, sorry. Okay, so essentially we've got 4 minutes left. Let's do a filter. Let's implement a filter right here. Which filter should we implement?
Color invert. Simple.
Somebody else. Give me a somebody. I think it's like a color invert master over here.
All right, color invert.
You know what? You guys are gonna get it. That's it. I'm gonna give it to you. CI.
The one that gives you the edges.
You want to do a sepia tone?
Edge detection.
Edge detection? We're not gonna be able to do edge detection with this one. There's not a built-in edge detection for core image. We will get to that next week. We'll use OpenCV. All right. So clearly we're gonna have to invert it. Okay. So filter with name.
Black and white there.
Do they have a Laplacian?
No.
Do they? Because that would be an edge detector. Fine. Sepia tone it is. See, if I had you guys around, I would never make a programming mistake ever in my life. Okay, so how do I apply it right here? Filter, set value, camera, image, for key, K, CI, input image, key. All right, so I set the input image right there, and I'm gonna say camera image is equal to filter dot output image. Good? So now I'm gonna have this awesome sepia tone filter. We should do lecture like this from now on. I look better.
Only if we get the code in sepia as well.
Anyway, for next time, what we'll do is we'll do some distortion filters that are on here. So these are nonlinear filters that are applying some distortions like pinching and that kind of stuff. And then we'll do some face detection. Okay? Happiness? Good? Let me make sure there's not one more thing that we can get through. Updating filter parameters. Oh, you know what? We can do this. I got 2 minutes. Okay. So we can update filter parameters on the fly, right? And actually, I just did that in the demo, right? So let's say I had this pinch distortion filter, right? Where I set up a center, which is right here, and a radius for my pinch distortion filter. I can create that filter out here, and then inside of my block, I can do this code right here, which has a lot to it, and I'm just going to explain it, and then we'll be done. So I get a camera image that's on the input, then I call this thing filter set value, and I get the center from self right here. Why is this weak self? Right, so I've declared this as weak type of self, weak self equals self. Why would I do that? So I don't have a circular pointer. When I create a block and add it into this video analgesic, I'm adding it to self.videoanalgesic. So it has a strong pointer to the block. If I try to pass in self into the block, it's going to have a strong pointer back to self. That will never be deallocated by ARC. And I got a memory leak. Okay? The way around that, I just pass in a weak pointer to self. And that way, if self exists, I can get access to any of the stuff that's in it. Happiness? Right? And I can update all the parameters that are there. And I think we'll do the CI pinch distortion next time. We're done. At exactly 4:50.